Have you ever stared at a massive airplane soaring in the sky and wondered, how on earth does that thing stay up? Is it magic, alien tech, or pure science? Surprisingly, even scientists debate the real reason. One side says it's all about Bernoulli's principle, while the other points to Newton's laws. So, who's right? And more importantly, how do airplanes really fly? Buckle up because we're about to decode the science of flight like never before. To understand the debate, we need to break down the basics. Let's talk about Bernoulli. According to his principle, when air flows faster, its pressure drops. An airplane flies thanks to four forces: lift, weight, thrust, and drag. Lift is what keeps the plane in the air, and it's the most debated force of them all. Why? Because scientists can't fully agree on how lift is generated. The mystery lies in the shape of the wing, called an airfoil, and how it interacts with the air. An airplane wing is curved on top and flat at the bottom. As the plane moves forward, air travels faster over the curved top and slower under the flat bottom. This creates lower pressure on top and higher pressure underneath, pushing the wing upward. That's lift. Simple, right? But wait, some critics say that's not the whole story. Why? Because the air doesn't have to meet at the same time on both sides of the wing. So maybe there's another force at play. Now enter Sir Isaac Newton. His third law says, for every action, there's an equal and opposite reaction. As the wing pushes air downward, the air pushes the wing upward. That's lift. In this view, it's not about pressure differences, but about deflecting air downward. Think of it like bouncing a ball. Push it down, it pushes back up. Many modern aerospace engineers actually lean toward Newton's explanation, or even a hybrid model combining both Bernoulli and Newton. So who wins, Bernoulli or Newton? The truth is, both are right, in their own way. Bernoulli explains the pressure differences. Newton explains the downward deflection. In real flight, both principles work together. Engineers use complex fluid dynamics and simulations to fine-tune wing designs, blending both concepts for maximum efficiency. So it's not a rivalry, it's a scientific team-up. Birds instinctively use Newton's principle by pushing air down with their wings. Jet wings, meanwhile, are designed with Bernoulli's curves for pressure-based lift. Helicopters. They spin their blades to create both speed and deflection. So every flying machine uses a mix of smart design and physics, guided by both Bernoulli and Newton. Understanding how airplanes fly isn't just for pilots or scientists. It's a reminder of how nature and physics work in harmony. And even when the world's top minds debate a concept, the result is often a deeper truth. So the next time you see a plane taking off, remember, it's not magic, it's science in motion, powered by both pressure and push. Liked what you saw? Then hit that like button, share your ideas and thoughts in the comments, and subscribe so you never miss a moment